Hi dear students. So today we're gonna start with our first classes, online classes in fact, due to the circumstances of COVID-19, and we're gonna have a continuation of our previous class. And as we said before in our previous classes, online classes in this channel, I need you to open your handouts with you and follow up with me when I'm explaining the classes. Okay, so in this class, we're gonna talk about the footing and pedestal exercise as we have here in our topic. Okay, and this footing and pedestal, we're gonna calculate the quantities of rebar. However, we can more elaborate in this exercise. We can ask you for having for calculating how many cubic meters for concrete and how many square meters for formwork and maybe other things. And maybe afterwards we can elaborate more in this question also and ask you about the pricing or the costing of these items. So in this question it will be easier than that, and it will be like just we're gonna explain how to calculate the weight of the steel per ton. And as you can see here in these photos, this is we're just exhibiting or illustrating the steel reinforcement and concreting and the other works related to from the side related to the footing work. And also I will show you here in this video a real world practice from the site itself. I have embedded this video in this class to show you how to calculate the pedestals at the length of the main bar of the pedestals, like in here, or maybe if you wanted to continue your bars for the next step, which is the column. So here you can see the pedestals while concreting, and then afterwards the work when it's been done, concreting done after a few days, we started the backfilling process and compaction. Okay, so in this exercise we're gonna have like a footing. It shows here like it looks like a rectangular, but in fact it's 2 meters by 2 meters, so it's a square. And the exercise says that we have footing having a length of 2 meter, width 2 meter, having the thickness of 0.250 meter. The main bars are 12 mm at 150 cc, and distribution bars is also 12 mm at 150 cc. The footing clear cover is 50 mm from the top, and you can add here from the top and sides also, in fact, top and sides. And from the bottom it is 75 mm, and we said that from the bottom 75 mm is more than the sides on the top, because you know this is the part, this is the bottom part of the footing, which is having the load, and it is in direct contact with the ground, so it needs to be more covered, because the cover, as you know, it's like a shell or a protection for the reinforcement inside the concrete itself. Maybe someone else is asking, well, so what? Because all the footing is covered underground, but the pressure of the concrete, or the pressure or the load of the footing is going down from this, going down from the top to the bottom of the footing. So the main load will be here on this, and the earth, if there is any like a humidity, or if there is any like water table in this area, it will be first from the bottom of the footing. So the question is asking you to calculate the quantity of steel is going to be used in this footing. As we said that this is the only thing, this is the only requirement in this questions, and this is a simple requirement, just to calculate, to measure the quantity of the steel by ton. However, we can elaborate more in this question. So let's see what are the data that we have from this question. So we have the length of the footing 2 meter, and the width we have it also 2 meter, with the thickness of the footing itself is 0.25, meter. The main bar spacing, it's like 12 mm first, and the spacing of the main bars is 150. Okay, cc, center to center, distribution bars 12 mm at 150 cc, which doesn't make any difference because it's like a square section footing. A clear cover 50 mm from the top and sides, as we said, and 75 mm from the bottom. So what we want to do here is like that. The first step is to calculate the number of bars. First of all, we have to calculate the number of bars here, how many bars we have, the distribution bars, how many main bars we have. Then afterwards we can calculate the weight of each one of them. Then afterwards we can do the summation. So which we are going to use in the footing. The first step to calculate the number of bars, and in the second step we will calculate the cutting length, means the length of each bar of these bars, we will calculate the cutting length of the bars, and last we will calculate at the last stage, that means we will calculate the weight of the reinforcement bars. So so this is a section of the footing itself, and it shows the way of the reinforcement, how it should be. And so these are the rectangles. This shows that the concrete cover block, which is 75 mm, as we said, and you can see here the dimensions. And this is the 50 mm from the top, and also from the sides you have 50 mm here. And when you calculate the steel bars, you have to take in account that this is a 12 mm bar, for example, and when you want to calculate, you are calculating the center line dimensions of the bar itself. Why? Maybe you'll ask that this doesn't make any difference. It's just like if you are taking this from the center or from the top surface of the bar, it's just like 6 mm. This is very important when you are working on high quality work, because if you are not calculating from the center of the bar, you will miss sometimes some millimeters from the cover block, from the sides or from the top or whatever. And that means like if you have to have like 50 mm cover, this will be less than that. Maybe it will be 45. It will be sometimes rejected due to quality control when they are doing inspection. Quality control inspection, they will refuse this kind of work because you have you are not fulfilling the requirements of 50 mm concrete cover. So you have to take care of this one, and you have to take care that when you want to calculate the length of this bar, it has to be taken from the center of the bar itself. So this is why when we calculate, we will say that the number of main bars, it will be the total distance minus the clear cover divided by the cc, how many the spacings, plus 1. So the number of bars, it will be like 2 meters, the total distance, the 2 meters, as we said here in our plan. The 2 meters will be divided by will be so we are getting the number of spacing effect, because since we are dividing by the spacing itself, so we'll get the spacing. So for example, we got like the result of this one, it is like 13. Okay, so that means we have 13 spacing here. So if you have 13 spacing here, that means you have 14 bars. Like for example, let me make this one easier for you. Like we have these two spacings. This is what we have calculated, because we have divided our distance by the spacing itself. So we are getting the spacing impact, and the spacing of two spaces, it is consisted of 3 columns. So this is why after these calculations we add 1 in order to get the real number of bars. So this is why we are doing, every time we are doing this type of calculation, number of bars, we do plus 1. Okay, so now we have the number of bars according to the calculations. We have it like 14 bars, and then we want to calculate, as we said, we want to calculate the length of one of these bars. Then we have to multiply it with the number of these bars, which is 14. So how can we get the length of the bar? As we said, it will be calculated from the center line of the bar itself. So we'll say the total length, okay, this is the total length, minus 2/2 of the diameters, because I want to get rid of this part, and then you want to get rid of this part, plus clear covers, which is 0.5 or 0.05, okay, and afterwards plus 2 thickness of the footing, 2 thickness of the footing itself here, because I want to calculate now this one and this one, so it will be multiplied by 2. The thickness of the slab, or the thickness of the footing itself, sorry, minus the bottom and top, the clear cover, minus half, which is this down or bottom of the center line, downside of the center line of the bar, half of the diameter of the bar. So if we add these, if we change these things to numbers, we will get 1.676 meter. That means length of one bar. So length of one bar into the numbers of the bars which we had already in the first procedure, and this is 14. We will have the total length of 23.464 meter. So now we want to get the final step. We want to get the weight of the bar itself. So it will be the diameter squared to the power of 2 divided by 162 into the length that we have got. So it will be 0.89, and this, by the way, this formula is to get the weight of the steel bar per 1 running meter, the weight of the steel bar per running meter according to its diameter. So the total weight will be 20.88 kg, and it has to be changed, or it has to, sorry, to be converted to the tons, because we are dealing with the steel, we are dealing with ton as a unit. So it will be divided by 1000, and this will be 0.021 ton, and this is the first type of bars, which is the main bars. So now we will go back to the distribution bar, and the same procedure will be applied here. Also, we need to know the number of bars. So the total distance minus the clear cover divided by the center line, center to center, plus 1, as we have explained before, we will get 14 bars. Here, if we want to get the length, little bit we have something which is a little bit different. Let me show you here. If you want to calculate these bars, okay, these bars, you have to know that these are laying on the top of this bar. So that means when we do the subtraction, we have to subtract the half of the diameter of the bar, plus we have to subtract the diameter of this bar underneath these bars that we are calculating. So let's go to the cutting length of the footing, main bar or distribution bars. Length, which is the total length, as we said, the 2 meters, minus 2/2 of the diameter of the bar, as we said here. 2/2, this is, we want to get rid of this one, we want to get rid of this one, and also we want to get rid of the clear cover from both sides. And then afterwards we have the clear cover, we have 1 and 2 into the thickness of the footing minus the top and bottom clear cover, minus also the full diameter of this bar, the underneath bar, and the bar itself, it has to be, half of the diameter has to be subtracted also in order to get the center line of the bar itself. So if we apply these numbers, we will find that the length of the bar, of one bar, will be 2.102 into 1429.428 meter. Again, we'll apply the same procedure. D square divided by 162 into the length, we'll get the width in kg, 26.19 kg equals 0.026 tons, and now we have this tons and that tons, and we will have to add this one, this weight to that one, and we'll get the total weight of the steel bar which is used in this footing. Also, I have to take in account maybe sometimes the footing is not coming like this way. It will be top and bottom reinforcement. So we have this bottom reinforcement, and we can sometimes have top and bottom reinforcement. Also, which is something else I wanted to highlight, in fact, which is sometimes the givings of this information, especially in your practical life here. Sorry, you'll have it in this way, just like a table of footings. This is the number of the footing or the code of the footing. It will be F1, for example, F2, F3, and something like that. The dimensions of the footing itself, you'll find it like this way, and you have top and bottom reinforcement as here. As of now, we have in this question or exercise, we have just like the bottom reinforcement, but sometimes you will find the top and bottom reinforcement. They are not saying footing distribution bars or sometimes and main bars. They're saying short and long bars, which is, it doesn't make any difference here in our example because it's a square 2 by 2. But here it says also for this example I'm having 2 by 2, and they are saying short way and long way. So the short way will be the shortest one, and the long way will be the longest one, and short and long also for the top and bottom reinforcement. This is about the class of today, and we have explained how to calculate the footing steel reinforcement, the quantity of this one, the top the quantity of the reinforcement, and this is only a quantity, as we said in the beginning of this class, and it could be elaborated to another stages, like maybe the question will ask you to calculate the formwork area, the volume of the concrete itself, and then afterwards the price, the costing of each one of these items to get the total cost of materials of each footing. Okay, so this is our class for today, and see you inshallah in the next class. Thank you very much for watching, and see you again. Hi. In this video I just wanted to highlight one point regarding the steel bars or the main steel bars for the pedestal. So here we have the footing, and we have this which is called the pedestal, and when you calculate the main bars length, you need to take into account the development length, okay, for the footing. Okay, then afterwards you need to calculate the height of the pedestal from the footing itself minus the concrete cover, which is 70 mm mostly. Then afterwards the length until the top of the the bottom of the plinth beam, then afterwards the thickness of the plinth beam, then afterwards the thickness of the slab itself, then afterwards the overlap for the coming column. So for the quantity surveyors, when you want to calculate the length of the steel bar here, especially in the site, when you want to give the instructions to the steel fixer to cut the steel bars, you have to take into account, as I told you, the development length, the thickness of the footing itself, the thickness of the cover, concrete cover, then the thickness of the plinth beam, the length of the pedestal, the thickness of the slab on grade, then afterwards the overlap for the next coming column.